Welcome to UGC's ePathshala lecture series. Today, the subject is Introduction to Visualization, and in today's module we will be looking at the different types of visualization and the design principle associated with visualization. So, a gist of what we are going to learn. Today we will be learning at what are the different types of visualizations that are available. We will also learn visualization and with respect to various aspects of visualization. We will be looking at the design principle associated with the visualization, and we will also learn about certain examples of visualization design techniques. So, to start with, let us see what is the purpose of visualization. As we have already seen in the previous module, that with the help of visualization it is possible for us to do certain kind of self-study or analysis. We can also go in for some kind of interactive exploration, and we try to gain understanding of certain principles. And with the help of visualization, it is possible for us to make some kind of understanding between the peers. We can also probe inside the problem domain. It is possible for us to analyze the data, and it is also easy. Visualization acts as a tool for easy communication between the peers. It also helps as a tool for presenting something to the general public, and then overall it is a presentation of data, and with the help of this it is possible for us to communicate with the general audience. If we look at the visualization principle, we can classify them into two types. One is expressiveness, the other one is effectiveness. Expressiveness in the sense it tells that you have to encode all the facts into the result sheet, and we are supposed to encode only the facts into the result sheet. Whereas effectiveness talks about it depends on the capability of the perceiver, and it encodes some more important information in a more effective manner. So, expressiveness and effectiveness both together, they form the interesting principles of visualization as such. So, already we have looked at the visualization pipeline in the previous module. So, according to the visualization pipeline, the simulated or observed data set is first filtered out, and then it is mapped onto some geometrical attributes, and these geometrical attributes are later mapped onto the viewing attributes and object attributes, and finally they are rendered onto the screen, onto the display device, and the final rendering can be either recorded or it is supposed to be displayed to some appropriate end users. So, visualization also helps in amplifying our cognition or knowledge. It increases the resources, it reduces the search effect, it enhances the recognition of patterns. With the help of visualization, it is possible for us to perform certain kind of perceptual inference. We can also do certain kind of perceptual monitoring onto a manipulatable medium. So, with the help of visualization, we can say finally that it amplifies the cognition of the knowledge. If you look at visualization as such, it consists of two subjects. One is the scientific visualization, which is visualization of physical data. Here they have given an example. The ozone layer that is present around the earth can be visualized in this manner. The other kind of visualization is the information visualization, which is the visualization of abstract data. The example given here is the automobile website, visualizing the links that are available in the automobile website. So, these two are different flavors of visualization. One is the scientific visualization, the other one is the information visualization, where in scientific visualization we are talking about the physical or the raw data, and in the case of information visualization we are talking about the abstract data. So, if you look at the pros and cons of scientific and information visualization, in scientific visualization the focus is on visualizing an entity which is measured in a multidimensional space, whereas in the case of information visualization the focus is on visualizing the set of observations which are going to be multivariate in nature. And in scientific visualization we can see the underlying field is recreated from the sampled data, whereas in information visualization there is no such underlying field. It is the data itself that we want to visualize. In scientific visualization it is easy for us to understand the relationship between the various variables, whereas in information visualization the relationship between the various variables is not well understood. So, these are the pros and cons associated with scientific and information visualization. With respect to the information types, we classify the visualization as multidimensional, one-dimensional, two-dimensional, three-dimensional, hierarchies and trees, networks and graphs, and document collections. So, examples of one-dimensional information types are timelines. Example of two-dimensional information types are maps. For three-dimensional we have volume representation. For hierarchies and trees, we have directory representation. For networks and graphs, it is web and communications. For document collections, we have digital libraries as example, and for multidimensional information type, we have multidimensional data set. So let us look at each and every data in detail. So for the one-dimensional data set, if we see, usually the data set is linear data. So examples are textual documents, source code, etc., which are going to be linear in nature. The problems that we need, the user needs to the user problems that are associated with this one-dimensional data are users are supposed to find out something, to replace something, or users need to count certain information or certain variables within the document or within the linear data, and the encoding is supposed to be done with respect to the fonts, the color, the size of the object, the layout of the object, the scrolling and the selection capabilities. Product examples for these are text editors and browsers. In the case of 2D information types, examples of planar or map data, where we have the applications as geographical maps, floor plans, newspaper layouts. These all come under planar or map data. The user problems associated with the 2D information types are to find the adjacent items, to search for a particular containment, to find the paths within the data, to filter certain data, or to get details on demand. Some of the encoding principles that we use here are size, color, layout, arrangement, multiple layers. Product example is CAD. In the case of three-dimensional data, 3D information type, we have the real world objects. Examples are building and the human body. User problems associated with this are to find out the adjacency in three-dimensional data set, to find out the inside-outside relationship, to look at the position and to get the orientation of the information. Encoding principles, if we see that are applicable on three-dimensional data set, are overviews, landmarks, transparency, color, perspectiveness, and stereo display. Product example is CAD. Temporal data is another type of data wherein the users come across time series data. Example for such kind of time series data are medical records, project management, historical presentation. User problems associated with these time series data are finding all the events before a particular time or after or during some particular time period or moment. Encoding principles that we use here are timelines. Next comes multidimensional data. In the case of multidimensional data, examples are relational and statistical databases tuples. The user problems associated with these kind of multidimensional data set are to finding out patterns, to find out clusters, to find out the correlations between the various data set, to find out the gaps and outliers that exist between these multidimensional data set. The challenges here are to simultaneously display many dimensions of the large subset of data, to create displays that best encode the data pattern, and then to rapidly select a subset of tuples or dimensions. These are some of the challenges that are associated with multidimensional data set. Next, we have the tree type data, where we come across exponential data type. Such examples are hierarchies and tree structures. User problems associated with these kind of tree type data sets are finding the structural properties, to find the height of the tree, to find out the number of children, to find out the nodes which has the same attributes. Some of the encoding principles that are associated with these kind of tree type data are node link diagrams, allowing the encoding of linkage between the entities, tree maps where child rectangles are present inside the parent rectangles. Product examples are Windows Explorer and internet traffic. Next comes the network data set. Examples are graph data. Applications are to find out user problems associated with this are to find out the shortest path, to find out and topology related problems. Encoding principles that are associated with these kind of network data set are node link diagram and matrix kind of diagrams. So in all these various data types we have seen, the basic visualization task that can be performed over these data types are overview, to find out the overview of the collection of a data set, or it is possible for us to zoom in or zoom on into objects of interest. We can filter out uninterested items, or we can filter out interested items and show it to the end user. We can show details on demand, that is, it is possible for us to view the details only when the user is in need of those details. We can relate, that is we can view the relationship between two attributes. We can we can associate certain history elements, like it is possible for us to undo, redo or refine the given data set, and it is also possible for us to extract a subset of the data set that is available. These are the various basic visualization tasks that can be performed over the given data set. So if you look at the user tasks, for the user, it is possible for him to perform some of the easy stuff, like to find out the minimum and maximum of the data that is available, to find out the average or percentage of the data that is available, and these only involve only the data item or the value. The hard stuff with respect to user tasks are to find out patterns or trends or distributions or changes that change over time, to find out outliers or exceptions from the graph or from the visualization, to find out the relationships and correlations in a multi-way data set, to combine the min-max and to find out the trade-offs, to find out clusters, groups, comparisons and context, to find out anomalies and data errors, and to find out paths. So these are some of the hard stuff or the user tasks that can be performed on the visualization. The easy stuff can be performed over an Excel data sheet, whereas the hard stuff can only be performed over the visualization. So based on this, we also classify the visualization techniques based on the type of information. So if you look at the type of information, as we have previously seen, it is visualization of information structures like trees or networks, or it can be visualization of multivariate data set like one-dimensional, two-dimensional, 3D or n-dimensional and temporal data set, and then it is visualization of workspaces like windows, web pages, documents, etc. Based on how we interact with the data, we can classify the various visualization. So this is a classification of information visualization technique based on the interaction that the user performs with the data set. Overview is fish-eyes kind of data set. Zooming, the examples are table lens kind of data set. In interactive filtering, we have magic lenses. In brushing and linking, we have an example as XGOBI, and details on demand example is given as Spotfire. So these are certain applications wherein all these kind of interactions can be performed over the data set. In the fish-eyes view, it is possible for me to get an overview of the entire data set. Using table lens, it is possible for me to zoom in and zoom out certain objects on the screen. Using magic lenses, it is possible for me to perform certain kind of filtering. I can filter out certain data set and I can just look into the data set by using the magic lenses. By using the XGOBI interface, it is possible for me to brush and link certain data that are available, and then it is possible for me to get details as and when I need in the Spotfire application. So some of the information visualization design issues are: how do I select what data should we choose to visualize? Since we have huge amount of data, we don't know which kind of data or which set of data that we need to visualize on the screen. Then next comes a representation. How should the data be represented? With what colors it is supposed to be represented and where it is supposed to be represented. So this is also a big challenge. This is one and is considered to be one of the design issues. Another design issue associated with the information visualization is presentation. How is it possible for me to present the entire data set? Because I have too much of data and the display space is very small, too little display space is available. So how is it possible for me to present the entire data set onto the display device? Then scale and dimensionality. If I have more number of variables to visualize, how do I visualize more number of variables that are available or n-dimensional data that is available? And then what kind of interaction, how the user can interact with the data and how the user can explore the given data. So that also is a challenge associated and is considered to be one of the information visualization design issue. So if we look at this information visualization applications, we have complex documents like biographies, manuscripts, data structures that can be visualized. Then histories of data can also be visualized like patient histories, students' records, etc. Data classifications like table of contents, organization charts, etc. can be visualized. Network data like telecom connections and data usages, highways, etc. can be visualized using these some of the visualization techniques. So here comes certain examples of information visualization. This is Stephen X CSoft, which is a tool which is useful for visualizing the source code of the source code. So here actually we have the source code in a particular specific programming language. So we have various lines of code. These are represented here. The number of times modifications performed over the lines of code are represented using the color code. So this is a color code that is available, and for this particular set of lines, these many number of yellow represents more, red is the most times the modifications has been performed, and blue represents the least number of times a modification has been performed over the source code. So this entire line segment tells at what time and at how many number of times the source code has been modified for these set of lines. So similarly, we have the source code modification data to be visualized using this Stephen X CSoft tool. So looking at this, it is possible for us to infer that many a times your source code has been modified. It means that so many versions of that particular source code has occurred. Okay. So all these kind of, and we can also infer certain patterns. Which are the source code that are modified more frequently, which are the source code that are modified very less frequently, which are the source code that are modified together. So such kind of dependencies that exist between the source code can also be analyzed using this application. Next is the hyperbolic trees. So this hyperbolic tree, here we have two examples of 2D hyperbolic tree and 3D hyperbolic tree. This is displayed in a three-dimensional view. So these kind of, say, the websites and the relationship between the websites can be represented in the form of hyperbolic trees. So this is one kind of representation. So here we can see that we have so many web pages which are linked with so many other web pages, and they are linked in this manner. So next one is a themescape. Next information visualization example is a themescape generated by CATIA. It talks about the entire document. This shows the document and the changes that are made to the particular document. So themescape represents, and it also talks about the occurrence of the theme. Suppose if the document theme is about say a sports item, where all inside the document that particular sports item has been stressed, those areas are all shown as raised areas and shown in red color, and where all in the document the sports information about the sports is very less are shown as some blue color. So using, when looking at this kind of visual, it is possible for us to understand the location of the document where exactly the thematic content is high. If you look at it on the right hand side, we can see we have two red color peaks. On the right hand side corner we have two red color peaks. So these shows that in these two locations the thematic information is huge, whereas in the center of the document, if you see, the thematic information is very less because it is mostly of blue color and it is smooth in nature. So wherever peak occurs, it means that the thematic content is high in that particular document. So this is also another one example of information visualization. Next, this is another one interactive graphics application which is called as a home finder. Using this application, it is possible for an end user to check for homes. So he can, suppose a person who is interested in knowing whether, in renting a particular house, he has to give his entire preferences inside this home finder. He has to tell what can be the rent that he can afford, how many number of bedrooms should be there, what should be the size of the entire house, and all such kind of criteria can be given inside the home finder tool. And once we say search, automatically the home finder tool will show all the relevant homes that are available near the location, and with respect to our preferences, it will display all the relevant homes in the order of our preferences, so that the end user can go and select each and every house, and he can see what is the rent of that house, how many rooms are there in that house, and some kind of information related to that house can be made available. So this is also another one, interactive visualization, which is, the application name is given as home finder. So these are the different dimensions of the exploratory data visualization. So in one side we can see various data visualization techniques, and in one axis we can see the distortion techniques that are available, and in one axis we can see the kind of interaction techniques that are available. So in the data visualization technique axis we can see the data can be graph based data, hierarchical data, pixel oriented data, icon based data, or geometric data. And the distortion techniques, the distortion can be a simple distortion or it can be a complex distortion caused by a combination of various distortions. And in the interaction technique axis we can see that there are various techniques like mappings, projections, filtering, linking and brushing, and zooming, which are available in the interaction techniques axis. So these are the different dimensions of exploratory data visualizations. Then there are other examples like location probes, which is example is a film finder, which uses a location to view additional, data to view certain, get certain information about certain films. This can be used. Then we have the viewpoint controls. Examples are information murals. So in these kind of information murals, we can get the overview data as well as the detailed information. Then we apply distortion techniques. Examples are perspective walls, where we apply focus plus context approach. Then based on the data types, the information, the visualization can also be classified as univariate data, bivariate data, and then trivariate data visualization. In univariate data visualization, we can see usually the plots are in the form of dot plot, or it can be, this is a dot plot, or it can be in the form of a bar chart, or it can be in the form of an histogram. So these are examples of visualization of univariate data type. Next comes a bivariate data type, so wherein it can be represented in the form of a scatter plot with respect to x and y axis. Then we have the trivariate data type. So in trivariate data type, we can either use the 3D scatter plot or a spin plot, or it can be 2D plot plus any one attribute like size or color or whatever it is. So this is an example of a trivariate data type. Then we also have visual abstractions, which are based on interactive 3D animation techniques. So if you look at the visual abstractions, we have visual abstractions in the sense some of the information that is being visualized on the screen will be abstracted from the end user's view. So there may be some kind of abstractions or some amount of information may be beyond the, or may be situated as hidden surfaces on the visuals. So those are called as visual abstractions, which are not shown to the end user's eye. So such kind of, some examples of such kind of structures are hierarchical structures, wherein examples are cone trees. Then we have linear structures. Examples are perspective wall. We have continuous data displacement, which is in the form of data sculpture, and we have spatial data representation. Example is office floor plan. So these are examples of cone trees. If you look at this visualization, we can see that whatever is available at the front portion of the cone, that alone is displayed to the end user. Whichever is at the back of the back portion of the cone is not shown to the end user. So such kind of visual abstractions can be made available to the end user by using some kind of 3D interactive animation techniques. So cone tree is one such example. This is also another one cone tree, a 3-dimensional cone tree, wherein the user can just rotate the entire cone and see what are the data that are available at the back of the cone. Then perspective wall is another one example, the example for visual abstraction, wherein all the information is available on a particular wall, and the previous histories are also available with respect to this wall on various walls. So the size of the walls are distorted and the shape of the wall is also distorted to get to show an overview information to the end user. So this is an example of overview and detail, wherein I can get the entire overview of the full full information, as well as I get a detailed view of the specific information that I am in need of. So this is an example which is called as a perspective wall. Then we have spatial data representation, which can be represented in the form of webbook. Webbook and web foragers are examples of spatial data representation, wherein the entire data set is made available to the end user in the form of a book, three-dimensional book. So the end user can just flip through the pages of the book and he can look into the entire textbook as such. So this is also another one example for qualitative as well as quantitative data that is being displayed in the form of contour plots and line diagrams. Then this is also a wonderful example of a time varying data set, an example of static versus time varying data set, where the data set varies with respect to time. So a static data set is one which is static at a particular instance of time and at a particular point of view, whereas in a time varying animation it evolves around the timeline and the dynamic data is represented, or with respect to the point of view I can just rotate and see what happens. So such kind of animations are called time varying animations. Next comes the scientific visualization, wherein this is an example is to show the damaged structures that are available on the wall. The damages to the structures can be visualized in these forms. So these are examples of damaged structures visualization. This is also an example of damaged structure visualization, which is visualized in the form of an animation. So this is a contour surface, and with this the second visualization is an example of volume visualization. So these are composite representation of contour surfaces. Then we have another type of visualization which is called as stereo visualization. So in the case of stereo visualization, it is possible for the eye to have a kind of two and a half dimension effect, or similar to three-dimensional effect. So in this stereo visualization, the user has to wear in a glass where you will have the red and the blue glasses, and the shutter glasses have a frequency of work at the frequency of 60 Hertz and are synchronized with the projected images. The polarized glasses can be either linear, circular, or it can be synchronized with the projected images. So this is one example of the red-blue stereo visualization that is shown on the screen. So this visual will be more effective if we can wear these kind of stereoscopic devices and stereoscopic glasses, and if you view it will look as though it is a 2.5 dimension visualization. So till now we have been looking at the various types of visualizations and various attributes associated with the different types of visualization. Next we will talk about the various aspects of design aspects that are associated with visualization. If you look at the design aspect, they say that problem solving is the understanding of what is needed to solve a problem, which includes design and making choices and revisions. So when I try to design certain things, I need to make choices and I need to revise it so many number of times. What is visual communication? He says visual communication is the art of seeing by using pictures and words to convey information about different ideas and concepts. So instead of using words, I use an art to visually communicate something to the end user. The function and the information refer to the purpose and value of design, as well as the message conveyed will be with respect to the selected audience. So these are the design aspects. So if I look at the principles of design, well, let us look at the various principles of design one by one. The first principle is a balance principle. Balance is the optical illusion of equal spacing of objects. Giving equal spacing of objects with respect to the center point is called as a balance. So formal balance is symmetrical in nature, wherein the elements on a page can be centered and it can be evenly distributed either vertically or horizontally, and it is supposed to have some kind of symmetry among itself. So these kind of layouts, they often convey a sense of familiarity or elegance or a sense of serious thought. So balance is an important design principle. This is informal balance. In the case of formal balance, we have seen that the formal balance should be symmetrical in nature, which means the elements are supposed to be placed at equal distances to each other. In the case of informal balance, it is asymmetrical in nature, and moreover it involves placement of elements in a manner that allows the elements of varying visual weights to balance one another. So here we can see that there are two different objects. One object is placed in the front and another object placed at the back, but there is no balance between these two objects with respect to the weight as well as with respect to the size of the object that is being shown. So for example, it is possible to balance a heavy weight with a cluster of lighter weight objects. So in this example, we have seen that a heavy weight object is represented in the front and a cluster of lightweight objects are represented at the back, so that it is possible for them to perform some kind of informal balance in the visual. So this is another one interesting design principle. So these two are examples of informal balance, wherein we can see an object which is placed in the front has got more weight when compared to the object that is placed at the back. So similarly here we can see that the object that is placed at the back has got more weight when compared to the objects that are placed in the front, but in the front they try to balance it informally by adding more clutter of objects. The next principle of design is a rhythm. So rhythm is a reoccurring movement or pattern which can produce a feeling of motion in design. So it can, the rhythm can be based on the size, shape, color or spacing or angle and texture of the material. Different types of rhythm will produce different effects in the design. So there can be various types of effects that can be produced using this rhythm. It can be repetition, that is repeating similar elements in a consistent manner, or it can be a variation which is change in form, size or location. So these are examples of rhythms which try to convey a feeling of motion in the design. So these are different examples of rhythms. So if you look at this bubble, it conveys a meaning of a feeling of motion within itself. So these are also examples of rhythm, wherein in this example we can see that a particular pattern is being repeated so many number of times, and here it is not the same pattern is repeated but with varying form, size and location. The next design principle is proportion. Proportion is the relative size of an object in comparison to the entire object. So if we look at this particular object, the head part of this particular object has got more size when compared to the rest of the objects. So there is a kind of proportionality that exists between the head part as well as the body part of the object. So they say that a caricature is funny because the head is out of proportion. The head is very big when compared to the body of the entire object. So if you look at this human being, the entire body objects are always in proportion with each other, whereas in caricatures like this we can see that the face as well as the body are not in proportion with each other. So these are different caricatures where we can see the proportionality is not being maintained, wherein the head is of different proportion when compared to the size of the body. The next interesting design principle is emphasis. Emphasis is a method used to draw attention to a part of a design by making it as a focal point of the main idea. So with the help of emphasis, we try to draw the attention of the end user to specific part of the visual. So these kind of emphasis can be made using certain common techniques, like we can use contrast elements, like either one element can be made very big or small or thick or thin. We can use different colors for most important elements or attractive colors for the most important element. We can reverse an element out of the background. So these are certain techniques that we try to follow to provide some kind of, or to add some kind of emphasis to a particular design. So these are examples for emphasis. If we see here, the dots are being emphasized by showing us, by having different shapes, having different color when compared to these blocks. So here we can see that the inner square is being emphasized by having a different color. Similarly, here also the inner square is emphasized by having a different color. Here we can see that the entire black part is emphasized by having a different color with respect to the other part of it. So here also we have an A, and the mirror image of that A. Mirror image of the A is emphasized by providing different color to the mirror image of A. So these are examples for emphasis. So this is another example for emphasis, wherein the contrast achieves emphasis by setting the point of emphasis apart from the rest of the background. So the use of a neutral background isolates the point of emphasis. So this is a neutral background where there is no emphasis at all. contrast of color, texture or shape will call attention to a specific point. If it is possible for the designer to provide some kind of contrast changes with respect to color or texture or shape, it will try to attract the attention of the end user to some specific point onto the visuals. The next design principle is unity. Unity is nothing but the completeness and harmony of a design. Unity is achieved when all the elements belong together. Several methods of organization are used to produce this unity in design by grouping certain objects or using a grid or a subdivision space, and by repeating something. Repetition, which means repeating certain elements throughout the entire design. So these are the examples for unity. So a guideline is if an element can be removed without affecting the design, it wasn't needed anyway. So here we can see these yellow color blocks are being repeated so many number of times. Similarly here all these blocks are being repeated so many number of times. Even if one block is being removed from this visual, it doesn't matter anyway to the entire visual. But if this specific black color block is being removed from the visual, it matters a lot. So that is the importance of unity as such. Then this is also another example of unity. The design shows unity with similar muted colors and dress styles. So we can see there is similar dress style and similar colors being used to emphasize on the unity. The next element of design is a line. Line has length, position and direction, and it is either visible or invisible. A line is basically any distance. A line is actually called as a distance between 2 points, and a line can take a variety of shapes and functions. A line can act as a connectivity between two separate areas, or it can act as a separator to distinguish between or to disintegrate one unified area. A line can act as an outlier. A line can be used in graphs and grids. Line can also be used in symbolisms. So these are examples of various types of lines. So we have horizontal lines, and then we have grid lines, and then we have slanting lines. So these are certain examples of lines. This is line in design. We can see how lines are being used in visual structures in different ways. The next important element of design is a shape. So shape is any form that occupies and defines a negative as well as a positive space. Shape is anything that has width, shape or depth. There are three different types of shapes. So we can either call the shape as a geometrical shape, can be in the form of a geometrical shape, as triangle, square or circle. The shape can be some kind of natural shape like animals, plants or human beings, or the shape can be some kind of abstract shape wherein it is a simplified version of natural shapes. So these are certain examples of shapes. So letter A has its shape of its own. This is a geometrical shape. So these are various geometrical shapes. These are synthesized shapes. The spiral is a synthesized shape. So here we have geometrical shape examples, triangles, squares and circles. Natural shape examples with animals, plants and human beings. And then we have abstract shape examples with abstract objects that are being created, which are simplified versions of natural object. The next element of design is a color. Color is represented as a hue of pigment or light and is produced by the subtraction of or addition of primary and secondary colors produced from light. There are different uses of colors. With the help of color, it is possible for us to attract the end user. It also acts as a visual stimuli. We can organize certain information using color, and it is also possible for us to provoke certain emotional response by using different colors. So here we can see when white light is passed through a prism, that is being diffracted as a spectrum. So we have various colors being produced in the spectrum. So visible spectrum is only a small part of the entire electromagnetic spectrum as such. Color is distinguishable by the eye. So these are various examples of colors. So here we can see the emphasis given to colors. Then the next element of design is a texture. Texture is a look and feel of an object. The appearance of the visual object depends on the kind of texture that has been applied over the object. So the texture can be in the form of patterns. So patterns are good examples of visual texture. Till now, to summarize in this module, we have been looking at the various types of visualizations like scientific and information visualization. We have also looked at the information visualization types like one-dimensional, 2D, 3D, trees and network kind of visualization. We have looked at various examples of information visualization, film finder, location probe, perspective wall, themescapes. These are good examples of information visualization. We have also looked at the design principles associated with the visualizations like unity, shape, emphasis, proportion, texture, color and balance. Thank you.